All right, this is truly the last video for this chapter because we're not going to cover 3.3 and 3.4. So this one is comparing functions. All right, Ariel saved up $3,500 for her summer visit to Seattle. She anticipates spending $400 each week on rent, food, and fun. How long can she afford to stay in Seattle? Now, a lot of, this could be, I don't even know where to start on this. We need a function to figure out what the heck's going on here. Do we have a way to get two different points? No, there's only two numbers here. So they're actually giving us the numbers that we need for our function. Okay. Ariel saved up $3,500. So I'm just going to give you our basic function. F of x is equal to b plus mx. All right, so I'm going to use the f. F is the amount of money she has. Of money she has. And x is based on what? What are they wanting to know? Each week. So x is representative of weeks. So it's always going to be based on pretty much your time of what's happening. All right. So the amount of money she has based on the number of weeks she can stay is equal to, so f of x is equal to, well, how much money is she starting with? What's her initial starting value? $3,500. That's what she has. Now, is she increasing that amount of money or is she decreasing that amount of money for each week that she stays? She's spending it. And last time I checked, spending it is subtracting. So she's subtracting $400 for each week she's there. This is a subtraction. All right, we have a function. Now we need to see how long can she stay? Well, she can stay until she runs out of money. And that's going to be where her f of x is. So the amount that she's going to have left when she has to book it from Seattle is 0. When she runs out of money, we need to see how many weeks that is. So we would set our function of x equal to 0 and solve for x. How many weeks does it take for her to get to 0? That's the question. So I'm going to solve for x. First thing I'm going to do is I'm going to add 400x to both sides. And I get 400x is equal to 3,500. Oof, that's nasty. Been doing so good this whole time. $3,500. All right, solving for x, we have to divide both sides by 400. And x equals, let's break out the trusty calculator. Remember, it's 8 point something, but I don't remember what it was. So 3,500 divided by 400, 8.75 weeks. So 8.75 weeks. Now, if on My Open Math, you're going to need to plug in 8.75 weeks. For me, if you were to say, if you rounded to 9, could she actually stay? Could she afford to stay 9 weeks? She ran out of money at 8.75 weeks. So if you wanted to say she could stay a total of 8 weeks instead of 8.75, I would accept that. If you told me she could stay 8.75 weeks, I would accept that. If you told me she could stay 8 weeks and then told me how many days that corresponds to, I would most definitely accept that, probably give you extra points, just because that's just extra work. So I'm just going to say Ariel can stay or must leave, can stay in Seattle, or can enjoy her vacation, however you want to say it, in Seattle for 8.75 weeks. All right, and that would be your answer. Next one. Jamal is choosing between two moving companies. The first is U-Haul, charges an upfront fee of 20 bucks. Then they charge 59 cents for each mile that's driven. The second one is Budget, and they charge an upfront fee of 16 bucks, then 63 cents per mile. When will U-Haul be a better choice for Jamal? So let's think about this. Budget has an upfront fee of 16 and U-Haul has 20. So right off the bat, I'm saying that Budget, to me in my head, is cheaper just because of that. That's substantial. So I'm thinking Budget's going to be the cheapest up till the point that they're equal. And then once they're equal, after that, U-Haul is going to take over because it's only 59 cents per mile, whereas Budget is 63 cents per mile. So we're going to need to see where they're equal. First, I need to know what they charge. What's their function? So I'm going to say U-Haul. That's an uppercase, sorry. We'll say it's U-Haul's amount based on, well, everything is based on mileage here. U-Haul's amount per mileage is equal to their initial amount, or their upfront cost is $20. So that's their B. We put our F of X is equal to B plus MX. Then after the $20, they charge 59 cents per mile. Now that's 0.59 per mile. And M is miles. I just need to write that. U is U-Haul and M is miles. Budgets, let's go to budgets. So that's a function for U-Hauls. Let's look at budgets. Budgets, and we'll say that's B for the function, per mile, which I've already labeled over there, is equal to what? Theirs upfront cost is $16 plus, they're not going to be subtracting, they're going to be making more money, 63 cents per mile. So there's their function. And remember I said, I'm thinking up until they're equal, Budget's cheaper because it's only $16 for the initial value versus 20 for U-Haul. So I need to find out where they're equal, because after the point that they're equal, U-Haul will be the better deal. And this is what you could do in real life too. You could, if you're moving, contact these two companies and say, hey, or however many companies, and find out at what point are they equal. So if you're driving just across Jamestown, you're going with Budget, it's going to be cheaper if you're going from one part of Jamestown to another. But if you're going from Jamestown to Cincinnati, you're going to go with U-Haul because it's going to be substantially more than the minimum, than where they're equal. And we'll see what that point is. So if we want to know where they're equal, I need to just set them where they're equal. This part of the function is equal to this part of the function. So 20 plus 0.59 miles is equal to 16 plus 0.63 miles. All right, I'm going to solve for M. To do that, I'm going to put all my M's together and move my whole numbers together. So I'm going to subtract 0.59 M from both sides. and I get 20, that's a 20, is equal to 16 plus 59, 6 is 1, 2, 6, 3, 4 cents per mile. All right, now I need to move the 16 over. And I get 4 is equal to 0.04 M. Still solving for M, divide both sides by 0.04. And I see that M is equal to 100 when you divide. That means that 100 miles, if you drove exactly 100 miles, they would be equal in price. Okay. But if you're driving less than 100 miles, budget's your company you want to go for. If you're driving more than 100 miles, Jamal needs to go with U-Haul. Okay. The question was, when will U-Haul be a better choice for Jamal? U-Haul will be a better choice over 100 miles. And that's your answer. Next one is the town's population has been growing linearly. In 2004, the population was 6,200. I see points coming. By 2009, the population had grown to 8,100. If this trend continues, predict the population. Okay, we need to get a function first before we start predicting anything. So first thing I see is I have no way to get a function directly from the numbers given. I'm going to have to create one. So a town's population has been growing linearly. All right, let's get some points here. Point 1, point 2. In 2004, the population was 6,200. In 2009, population was 8,100. So now we can find the rate of change. All right, so the rate of change is M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to label these x1, y1, x2, y2. So now I can plug them in. M is equal to y sub 2 here is 8,100 minus 6,200 divided by x sub 2 is 2009 minus 2004. So M is equal to 8,100 minus 6,200. I'll break this over here. See, it's divided by 5. So 8,100 minus 6,200 is equal to 1,900. Divided by 5. So divided by 5 is 380. That is what our rate of change is. It's positive. So the town's population is increasing by 380 people per year. Okay, so we're going to need to have a function. Function of x is equal to b plus mx. And right now we know that our m is positive 380. We need to know what the starting value is. And I need to start labeling what these things are meaning. So it's at this point that I'm going to say, we need to solve for b. And I'm going to have a starting point of 2004 because we know the population is 6,200. Well, we can just solve for and see what the initial value is. But we need to know that x is equal to years after 2004. I'm going to say that's my initial starting point. Okay. And if I do that, I would know that my initial starting point is 6,200. Okay. And I could just say the years after 2004 is X. So then all I have to do here is say f of X is equal to 6,200, which is what the actual population was in 2004, but it's increasing by 380 people every year. We can do that. All right, so they want us to predict the population in 2013. Okay, well, we're looking at the years after 2004 for X. We're wanting to put an input in there that's going to be representative of the year 2013. So I'm going to come over here and say, okay, 2013, how far away is that from 2004? That's 9 years. So I'm going to go here and write my function. The function of X is equal to 6,200 people, and it's increasing at 380 people. Oh, shoot. I'm sorry. Let's give myself extra room. Let's erase this. It's equal to 380 people per year after 2004. Gosh darn it. It's being feisty today. All right. So I'm going to say, what is it in 2013, which is 9 years after 2004? Well, that's 6,200 plus 380 times 9. 380 times 9, I need to know. So 380, I guess I could have left that in there, times 9 is equal to 3,420. Then we're going to go ahead and add that to 6,200. So 6,200 plus 3,420 is equal to, let's see, there's a 0, 2, 6, 9. So in 2013, the population is 9,620. And that would be our first one to predict. In 2013, the population would be 9,620. There's A. When will the population reach 15,000? Okay, I'm going to do this on the next slide. That's why I gave myself more room. And I need to know that it's 6,200 plus 380x. Nope, I didn't give myself enough room. All right, so let's do it here. So in this case for B, they're saying, when will their population reach 15,000? So I'm going to say that that's where the function of X is. So 15,000 is equal to 6,200 plus 380 X, and we're going to solve for X. So I'm going to subtract 6,200 from both sides. And I get 380X is equal to, whip out the calculator, 15,000 minus 6,200 is 8,800. Now we have to get rid of the 380, so we're going to divide both sides by 380. So divide by 380. And we get 23 point blah, 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 blah. So 23 is the magic thing here. So X is equal to 23 point blah, blah, blah. Doesn't matter. What is X? It's the number of years after 2004. Well, it's 23 years. So I just have to take my 2004 and add 23. So in 2027, the population will reach 15,000. And that was our B. All right. Here's a you try for you to try. You can do it just like that one. So pause the video, attempt to do this one on your own. It's actually a little bit easier than the last one because they're not asking you to predict what it will be. You know, they're not giving you a population and ask you to solve for the T. So this is a little bit easier. So go ahead and try this one and then we'll talk about it. Okay. In 2004, a school population was 1,001. By 2008, the population had grown to 1,697. Assume that the population is changing linearly. All right, and then we're going to start answering some questions. So let's get a point in here. Actually, yeah, we've got 2 points here. Point stinker. I don't know what does that. Let's pull my sleeve up. So point 1 and point 2. All right, they said in 2004, the population was 1,001. And in 2008, the population was 1,697. So we need to find the rate of change. How much did the population grow between the year 2004 and 2008? Well, that's if you're thinking about the rate of change, that's the part in the numerator. That's the 1697 minus 1001. So I'm going to go ahead and start labeling these. X sub 1, y sub 1, x sub 2, y sub 2. So that is 1697, 7 minus 1001. So 1697 minus 1001, which is 696. So your answer for A is how much did the population grow the year 2004 and 2008? The population grew by 696. All right, the next question is how long did it take the population to grow from 1001 to 1697? And that's just the change in X. That's just your denominator portion of your rate of change of your slope. So that's 2008 minus 2004, which is 4. How long did it take for the population to grow that from 1001 to 1697? It took 4 years to grow from 1001 to 1697. Okay. What is the average population growth per year? That is actually calculating the rate of change. So the 696 divided by 4. And that's 174. So that's telling us that the population is increasing by 174 every year. So what's the average population growth per year? The average population growth per year is 174. find an equation for the population P of the school T years after 2004. Okay, so the population is P. And T is the number of years after 2004. It's being feisty. All right, so P of T is our function. We need an initial value. Well, they're saying T is the number of years after 2004. So what was the population in 2004? That's our initial or starting value. And it was 1001. Is it increasing, the population increasing, or is the population decreasing? The population is increasing by how much? 174 per year. Okay, that's per year after 2004. We now have a function, so that is our C. All right, now we need E. Using our equation, predict what the population of the school is in 2011. Now we can't just go plug in 2011 for T because that would be incorrect. T is the number of years after 2004. So we need to subtract 2011 and 2004. And it's a 7-year difference. So the population 7 years after 2004 is equal to 1001 plus 174 times 7. Okay, so that's equal to 1001 plus what? Bring over my calculator. 174 times 7 is equal to 1,218. All right, now we just add the two together. So that's 2,219. So the population, to answer E, the population in 2011 would be 2,219. And that answers all those questions. And I didn't need to use that extra spot. And that's it. That's it for linear functions. Let me know if you have any questions.